This is an example hopefully to help you with surface area. And so what we're going to do is we're going to find the surface area generated by revolving f of x equal to the square root of 4 minus x squared over the interval from -1 to +1 about the x-axis. So I have my region drawn there. So when x is -1, we have this point over here, and we have those lines as well, and then x equal to +1 as well. So there's our region that we're wanting to revolve about the x-axis. So we have a horizontal axis of revolution. So by definition for surface area, our surface area, since we have a horizontal revolution, our surface area is going to be 2 pi times the interval, and we need r of x, which is the distance that we are from our axis of revolution, which we'll go back up there and figure out in just a minute, times the square root of 1 plus, and then we have f prime of x, all that squared, which is the square root of 1 plus f prime of x squared is just the formula that you have for arc length. Alright, so back up here with my picture. I need to find r of x. So since we have a horizontal axis of revolution, I'm going to draw my rectangles in here, which this rectangle here is just going to represent the distance that I am from my axis of revolution. So the top of this rectangle is just a point on my curve here, which is x comma, and then my y value is the square root of 4 minus x squared, and the bottom here is some x value and my y value is 0 because that's my axis of revolution. So my distance that I am, r of x, is just the square root of 4 minus x squared. So that's the first piece that I need in my problem down here. So my surface area is going to be 2 pi times my bounds. So in this case, my bounds, they told me I want x to go from -1 to +1. So it's going to be -1 to +1 of the distance I am from my axis of revolution, which we found to be the square root of 4 minus x squared, times 1 plus, and then I need f prime of x, and I need to square that. Alright, so back up here. There's f of x, so I'll do it in blue right here. So f prime of x in blue, that's 4 minus x squared to the 1/2. So this is going to be 1/2 times 4 minus x squared, all that raised to the -1/2, times the derivative of the inside there, which is -2x, using my chain rule. So f prime of x is -x over the square root of 4 minus x squared. Or if you want to keep it as 4 minus x squared to the 1/2, you can. But since it's -1/2, I took it down the denominator. Alright, so that's f prime of x. And then I need to square that. So we'll put that in the formula and then we'll go through and square it down here. Alright, so this is going to be 1 plus, and then f prime of x, which is -x over the square root of 4 minus x squared, and all of that is going to be squared. So again, the couple of things I wanted to illustrate with this one example is make sure that you get your distance that you are from your axis of revolution, which is always going to be a rectangle that's going to be perpendicular to your axis of revolution. So in this case, my axis of revolution was the x-axis, so the distance that my curve is from there is going to be a perpendicular distance, which is why I drew my rectangle vertically in this case. So keep that in mind. And the other reason is the algebra sometimes can be a little tricky down through here, so that's the other reason why I want to do this example. Alright, so this is going to be 2 pi times the integral from -1 to 1 of the square root of 4 minus x squared times the square root of 1 plus, and then if I square this, this is going to be x squared over 4 minus x squared. Now, at first glance, that looks pretty ugly when you first look at that and try to figure out what you're going to do with it from this point on. The first thing you need to recognize is that both of those things are under the radical. So since they're multiplication, I can put those together as one radical. So I'm going to rewrite this as 2 pi times the integral from -1 to 1 of the square root of all this stuff. So this is 4 minus x squared sitting out here by itself, and that I'm going to have to multiply into 1 plus, and then I have x squared over 4 minus x squared. So that's the first thing you need to recognize, is that since that's a multiplication, I can put that together as one radical. And now I can just deal with what's underneath that radical. So this is 2 pi times the integral from -1 to 1. I'm basically now going to distribute this entire expression right here into both of my terms. So if I distribute that into my first term there, which is a 1, then what I get is I get the square root of 4 minus x squared plus, and then if I distribute this into my second term over here, if I distribute that into my second term, which is x squared over 4 minus x squared, then I have a 4 minus x squared on top and a 4 minus x squared on bottom. So those 4 minus x squareds are going to cancel, and I'm just going to be left with x squared. Again, you got to recognize that, otherwise you're going to sit there and stare at those product of those two radicals and not see where to go from there. But if you recognize that, first of all, it's multiplication, so I can write that as one big radical, and then when you distribute into both of those terms, then you get 4 minus x squared plus x squared, because my 4 minus x squareds cancel with that second term there when I distribute. So this becomes a simple problem. This becomes 2 pi times the integral from -1 to 1 of the square root of 4, and I'm sorry, this should be dx all the way. I kept forgetting to put that. My fault. And square root of 4 dx. So this is 2 pi times the integral from -1 to 1 of 2 dx. And we're home free from here. So this is 2 pi times 2x evaluated from -1 to +1. And that is going to be 2 pi times, upper bound 2 times 1 is going to give me 2. And then when I have a minus, 2 times -1, which is going to give me a -2. So that minus and that negative is going to make that a +2. And so what I'm left with is 8 pi there for my final answer for the surface area of that region. So again, just a couple of things that you have to be careful about. The formula is not that bad. You just got to memorize the formula. But a couple of things you want to keep in mind. If you're going to find surface area, then you need to make sure you find r of x or r of y. And whether it's x or y depends on whether your axis of revolution that you're using is going to be vertical or horizontal. But make sure that you find the distance that your curve is from that axis of revolution. So you're going to be finding a perpendicular distance, perpendicular from that axis of revolution. And then the other thing is your algebra can get a little tricky. So sometimes it'll simplify nice like it did here. Sometimes you may get to something that you don't know how to integrate. So if you had gotten to something that you didn't know how to integrate, then once you got a formula set up for the integral to find that surface area, you could use your calculator and figure out what a decimal value is instead of finding an exact value like we could here. Because you may get to something that you can't integrate as far as techniques that you don't know. And so at that point, once you had that set up, you would just use your calculator to find the approximation to that integral. Hope this example helps. And the next examples will be on some more applications that you have with integration.